Welcome to The Explainer. For years, quantum computing has felt like something straight out of a sci-fi novel, right? It's basically lived entirely behind these locked, heavily guarded doors at elite university facilities and massive research labs. It's always been incredibly impressive in theory, but practically, completely out of reach for everyday businesses. But wow, that reality is starting to shift in a massive way. Today, we're diving into the groundbreaking leap of quantum computing out of the isolated lab and straight into the real-world enterprise data center. We're going to see exactly how the hardware is finally catching up to the concept. But hey, real quick before we begin, please hit that like button and the subscribe button. It absolutely helps us keep creating these deeply researched explainers for you. All right, let's get into it. Okay, let's dive into this. Section 1, leaving the research lab, the end of the isolated experiment. So, for years, the massive hurdle here was the infrastructure gap. Traditional quantum computers were, well, they were absolute Goliaths. They were these isolated scientific experiments that demanded highly customized rooms, dizzyingly complex cooling systems, and just massive, massive amounts of power. But your everyday enterprise data center, our David in this scenario, operates on standard power using standard 19-inch server racks. You simply couldn't just plug a power-hungry quantum Goliath into a normal business facility. The gap was just way too wide. Which brings us to Section 2, the Equal One prototype, unveiled at Dell Technologies World 2026. Now, what's really interesting about this slide is how they completely sidestep that infrastructure gap. Instead of forcing a business to build a custom lab from scratch, the semiconductor startup Equal One actually designed a quantum computer to fit inside a standard 19-inch server rack. And the wildest part? It stabilizes at negative 459 degrees Fahrenheit. To put that into perspective, that is barely above absolute zero. We're talking literally colder than the vacuum of deep space. Though, hey, good news for your IT department. The rack itself is fully insulated, so they're not going to need winter coats just to swap out a hard drive. But seriously, quantum qubits require these extremes just to stay stable enough to perform calculations. So achieving that level of extreme, stable cooling inside a standard rack, running off standard power, it's a massive engineering miracle. Let's move to Section 3 and see how this builds. Inside, hybrid architecture, the power of silicon spin qubits. Now, you might be wondering, how on earth do you pack such extreme technology into a standard server rack? Well, the secret sauce lies in silicon spin qubits. Unlike older, massive quantum architectures, this specific technology uses the tiny magnetic spin of a single electron. And because they're actually built on silicon, they can be manufactured using existing everyday semiconductor processes. This right here is the foundational insight, the key that makes the entire system incredibly compact and highly scalable. But here's the kicker. Equal One didn't just build a pure quantum machine. They built a hybrid system. And I want to reassure everyone right now, quantum computers are not going to replace your everyday business servers anytime soon. Instead, they're going to act as specialized coprocessors. So your system handles everyday standard tasks with classical computing power, but the exact second it encounters a mathematical bottleneck, the kind that would take a normal server 1,000 years to solve, it just offloads that heavy lifting right over to the quantum processor. It's like this perfect partnership, and it fits seamlessly into your existing high-performance computing infrastructure. And this brilliantly illustrates Section 4, real-world quantum workloads, putting the prototype to work. The actual applications where this hybrid architecture is going to deliver massive value to the enterprise are staggering. We are talking about advanced logistics modeling, literally solving supply chain puzzles that would take classical computers weeks to calculate. Pharmaceutical simulations, which could dramatically accelerate new drug discovery, financial risk analysis, giving institutions a much deeper, way faster understanding of complex market variables, cybersecurity research, which is absolutely crucial as encryption standards evolve, and of course, large-scale optimization tasks across the board. These are the concrete, real-world use cases where conventional systems just hit a brick wall. For your business, this means solving previously impossible problems in minutes rather than months. However, as incredibly exciting as all of this is, we do need to ground our enthusiasm just a tiny bit. This is still a prototype. The hardware is actively catching up to the concept for sure, but Equal One and Dell haven't actually announced a commercial release date yet. It proves the form factor works, yes, but it doesn't mean quantum computing is suddenly super simple or that you can just go buy one tomorrow. So the crucial point is that the paradigm has officially shifted. As Dell noted at their showcase, businesses may eventually see these systems become part of mainstream high-performance computing infrastructure, rather than isolated scientific experiments. Developers aren't asking if it's possible anymore. They're actively engineering how quantum systems are going to integrate directly within your existing IT footprint.
Which leaves us with one final, incredibly important question. When will quantum computing become your standard IT infrastructure? The leap from the lockdown research lab to the everyday enterprise data center has officially begun. It's no longer just a theoretical goal. Those 19-inch racks are waiting. The only question now is how quickly will your organization be ready to plug it in? Thank you so much for joining me for this explainer, and definitely keep a close eye on this space.